Life is all about balance. You want to have a balanced bank account, balanced diet, balance between work and play, and a healthy inner ear to keep you from falling down all the time. And lots of things can mess up that balance. One bad night at the Cheesecake Factory and you might wake up with your finances, social life, and health out of whack. In science, our word for balance is equilibrium. You've heard of it. When the balance of some natural system gets disrupted, we say that it's out of equilibrium. But that's not always a bad thing, because nature usually finds a way to restore the balance. Like if a population of deer in a forest suddenly goes nuts and there's too many of them, they'll run out of food and space and predators will move in and the population will usually fall back to where the habitat can sustain it. Likewise, there's no reason that I can't enjoy the occasional Hot Pocket without destroying my so-called balanced diet. I just have to be sure to eat something that wasn't prepared in a salty lard factory to balance it out. We tend to think of chemical reactions as having a beginning and an end. You start with some reactants, some chemistry happens, and you end up with the products, and that's that. But that's not that, because you don't usually end up with pure products. Many chemical reactions seek balance too, and just like us, they have to work through the stress in order to find it. It's common, because it's usually helpful, to think of chemical reactions as simple, straightforward processes, but in reality, many reactions never finish. Ever. When reactants react to form products, what we usually mean when we talk about chemical reactions, it's technically called the forward reaction. But sometimes there's an opposite reaction that occurs, with the products changing back into the reactants. We call this a reverse reaction. Now, exactly what kind of reactions do this and why is hard to describe without busting out some 200-level chemistry kung fu, but it all goes back to our lesson about Gibbs free energy and reactions that occur spontaneously. Reactions are reversible when they can go forward or backward without any extra energy being used. Remember, this isn't just one reaction happening once. It's billions and trillions of reactions, and some of them might be going one way while others are going another way. And when the forward and reverse reactions occur at the same rate, that's called chemical equilibrium. And even though we all like the idea of balance in our lives, in this case it's not always a desirable thing. In fact, most chemists make their living using tricks to prevent chemical equilibrium, to knock it out of whack, maximizing the concentrations of the chemicals they want to produce at the expense of the balance that nature usually seeks. For example, consider the Haber process for making ammonia from nitrogen in the air. When we discussed it as a redox reaction a few weeks ago, we described it as a one-way complete reaction because that's all we needed to understand right then. But I was lying to you. Sorry, I'd rather you hear it from me than out on the streets. Turns out, the reaction really exists as an equilibrium. As nitrogen and hydrogen react to form ammonia, the concentration of those gases drops, making them less likely to collide and keep reacting. So the rate of the forward reaction slows down. At the same time, the concentration of ammonia rises, more ammonia molecules are available to break up into the reactant gases. And surprise, the rate of the reverse reaction speeds up. Eventually, those two processes reach a point where they happen at the same rate. At that point, there's no discernible change in the concentration of any gas. Nitrogen and hydrogen keep combining to form ammonia, while ammonia keeps breaking down into nitrogen and hydrogen at the same time. Notice that I did not say that the reaction stops. The reaction basically never stops. It's just that we don't notice any changes at that point, because everything that happens in one direction is perfectly balanced out by what happens in the other direction. That's why reactants like this are written with a double arrow, indicating that the process runs both directions. Like if I stand on a balance board, I never stop moving. I just shift my body back and forth to compensate for the motion of the board. When it moves left, I move right, and vice versa. And by doing that, I'm able to stay upright.